Hello everyone, let's discuss about the implementation of dichotomous search in MATLAB. Dichotomous search, as the name implies, is equal interval search, which is an interval reducing method and can be applied only for unimodal functions. This cannot be applied for multimodal functions which has many maximas or minimas. So let's say we are given an interval a comma b, and dichotomous search is an exhaustive search method where our aim is to reduce the interval a comma b such that it has plus or minus epsilon by 2 deviation. Dichotomous search gives rise to two scenarios. Let's say the function value is maximum at positive epsilon by 2 deviation. In that case, the region lesser than x1 doesn't have the function maximum. Hence, we delete the region. So our new interval becomes x1, the maximum upper bound. Case 2, let's say the function value is maximum at negative epsilon by 2 deviation. Then the new interval becomes the lower bound, x2, because the function value doesn't lie on the region beyond x2. Let's consider an example. We will implement a function 4 sin x 1 plus cos x on MATLAB. Our aim is to find the maximum of the function in the given interval 0, pi by 2 using dichotomous search. The epsilon value is given as 0.2 and the stop criteria is 0.5. First, we initialize all the variables. We also call a function dichotomous search, which takes the function, the lower interval bound, the upper interval bound, epsilon, and the stop value as input. The next step is to enter the while loop. The stopping criteria is implemented such that if the interval size, the modulus of the interval size is greater than 0.5, then we enter the loop. The given range 0.7854 is greater than 0.5, hence we enter the loop. We apply the dichotomous search algorithm. First, we calculate the function at negative epsilon by 2, which is 4.49, and we calculate the function value at positive epsilon by 2 deviation, which is 5.05. We observe that the function at the positive epsilon by 2 is greater than the negative epsilon by 2. Hence, we eliminate the interval lesser than 0.6854, which is the lower epsilon by 2 interval, because the maximum doesn't occur there. So our new search interval becomes the negative epsilon by 2 interval and the upper bound. We implement the same in MATLAB. We run the iteration 1 and our new interval becomes 0.6854, 1.5708. We then repeat the same process for as many iterations till the stopping criteria is met. So the stopping criteria is met at iteration 3, and the interval size is 0.37135, which is lesser than the stop value of 0.5. Hence, we exit the loop. We return the maximum value as the average of the interval. The output is approximately the maximum of the function. Thank you for watching this video. If you would like to learn about more content related to optimization, communication networks, or automatic speech recognition models, please consider looking at my GitHub repository. Thank you so much.